Let's go ahead. So let me start from the first. I believe we understood the robotics, like why we build robots, why we need robots, frankly speaking, and what robots do. We try to understand the intelligent also, right? Then we had a look at something like first level of intelligence, or the things which we are trying to build for so many years, around 14 odd years, right? So this is what we call self-driving cars. We try to use some sensors like lidars, cameras, radars, pressure sensors, speed sensor, motion sensors, so on and so forth. We had a look at good list of sensors also. Okay, let's move ahead. This is where we stopped last time. So what we're trying to do, we're trying to build machines which can do our repetitive stuff, right? So what we are trying to address predominantly here, okay, great. So predominantly what we are trying to do, we are trying to build some robots which will help us to do repetitive or laborious task. That's the prime importance why we use robot, why we develop robots, right? So let's try to understand how we do it, right? Let's try to understand, let's try to review goals of artificial intelligence. Machine we can build, right? We can build car, we can build quite a few repetitive system, but let's try to build in that AI, the artificial intelligence things. So for that, there could be two different topics which we can basically start on: to create expert system and to implement human intelligence in those system. What are expert system? These are the system who does something. Car drives us from one point to another, but that's a kind of singular execution. We want machine to do more than singular task. There are some tasks which we can call singular. A person sings, that's a single. A person sings and play instrument like guitar, harmonium, and various other things, right? So for that matters, what we do, this is what we call expert system. So they can do multiple things at a similar time. So that's why we can basically let them build some expert system for us, and then we can pump in some human intelligence into them, right? So let's see how. Let's try to understand how this AI works for us. So AI is a science and technology both. It's a combination of science as well as technology. So only engineer or only scientist can't do these things. They need to work together. How do they work together? Through computer science. So we need some computer science. We need to understand some biology, psychology, linguistics, mathematics, engineering. So we are trying to understand or trying to build something which is a combination of these few. There couldn't be many things, but let's try to understand what this combination means, right? Let's try to do how this combination will try to make us a robot. And the main interest is basically building artificial intelligence, building some intelligence within the overall expert system which we're trying to build, so that I don't have to teach them every now and often, or I don't have to program them every now and often. So what I do, I'll ask them to learn on their own, right? Because every time if I do program to lift your hand, to drink a water, it's really cumbersome, right? Because these are singular executions where you might normally write to have so many programs. So what I do, I write program in some parcels and build some logic into this machine. So if you do this, then next step could be this or this. And how do you choose that? Depends on the event. How the event is, choose from these three or four things. Could you understand me? So what we are doing, we are trying to build some expert system who can do multiple things, and then they can choose from which events, choose from the event or which things to be done. So what I'm doing, I'm trying to give them some decisive power. That's what we call decisive power. And we start building these, the events are nodes, and this decisive power is basically the choice they made. So we have a node and we have a choice. These are AI terminology. These are what we do in machine learning. We build some nodes and we build some decisive executions. Okay, so let's try to step. I don't want to really pile you up on very difficult terminology here, but I want you to understand. If somebody spoke something like robotics, you should understand what is a node, what is a decisive event after that, or what is a execution. Execution is of a decisive event. Node is the event on which the expert system should decide on, right? On the basis of node, it decides on which path to be followed, right? These are what we call multiple area to be choose from by the expert system. Could you understand me what I'm trying to say here? Anybody have any confusion, question to ask? Do you know nodes? Do you know the choice they were to made depending on the events? Simple thing, right? Not difficult. Okay, let's move to different applications of AI. What we've seen gaming, right? Okay, let me read the chat. Okay, I'll repeat again, no problem. So in the expert system, they can do multiple things. In multiple things, how they can choose from multiple options. So when I ask a expert system to sing, or when I clap, or to play guitar, right? And I'm just taking a sample here. I build a robot which can sing. So I have a speaker in his mouth, and I have some MP3 player, right, built into him. So when I clap, like Alexa, right? I use Alexa or Google Home. When I say Alexa, please play a love song, so Alexa start playing love song for me. When I say they're like voice commands given to this Alexa or Google Home. These are the predefined, pre-programmed robotics, small robotic system which can do singular tasks like singing, playing videos, playing some audio files, and so on and so forth. Now I can build a better things where it can do yes, Shri very rightly said, Shri can be one. So they can do multiple things. They can call also, they can talk, they can call, they can connect to human beings for talking or video talking. They can switch on TV. These are multiple choices available with these robots called Alexa, Shri, or Google Home, and there are quite a few available in the market. Okay, you also have Alexa and Sri. Wow, you're a rich man. Give me one then. No, I was just joking. Please don't worry. So this is how we learn, and these are basically we build some program into them. So whenever somebody speaks, that machine understand, and then it choose from the options available to them, right? So there's a node. So my command is the node or the event on which it chooses different program to run within themselves, right? As simple as that, right? Could you understand now? Or do you want me to repeat again? You can understand, right, what I'm trying to say here? I need a yes from somebody at least. Oh. Ishan, could you speak up? She'll have some challenge with the camera, I believe, right? Problem with the mic. No response. Could you hear me out? Could you hear me here? What I'm trying to say, could you hear me? Oh man, I stopped share also. That's the wrong thing to do. Let me start the share again. Yes. Could you hear me what I'm trying to say here?
Yes, sir. Yes, sir.
Okay, great. Thank you. So I can hear you, Darshil. That's really great thing. Okay, no problem. So, now let's try to understand what are the different type of AI system we can build. So there are some vision system, there are some speech recognition systems, okay? There are some, intelligent robots, what we talk about. Intelligent in the sense, we try to have them some choice and the decisive nodes built into them, right? Let's try to understand the current scenario of the robots, right? Could you see, dog-like picture on the screen? A yellow
Yes,
Boston.
sir. We can see it.
Yeah, you can see, right? This is one of the most advanced robot we can use as of today. These are load carrying robot. These are following robot like Alexa or Siri. These robots have been basically doing multiple things: physical, lift the weight, move the weight, and all those things, right? This robot specifically is called Spot. It used to name as a dog, then they've renamed it as a Spot. Boston Dynamics. It costs around 70 plus K, but if you go to a cheaper market on like even Amazon, on you can get such robots at $12,000. So in Indian markets around 6 lakhs or so. So these are costly ones. So what they can do, they can carry your weights to a certain distance. They can follow you. You don't have to tell them ki move right, move left. They can follow you. They have certain tab like remote where you can move them, you can make them dance and all those things. Let's have a look at the video. I got a video for you where we can understand how they made this robot. Let me share that thing with you.
So there's a toy robot, so that can be operated with a remote. Have you played with it, sir?
Yeah, and we're going to build one toy robot. Don't worry, we're going to build one. Okay, But let's try to understand how these work, because we need to understand where industry have reached, right? And then step by step we'll learn how to build them. Okay, let's try to understand. Okay, so Kaushik has joined us. That's great. Uh, Hi Kaushik. Good morning. How are you?
Hello, I'm sorry, like my
Hello.
Wi-Fi died, so like,
I can understand. I can understand. No problem. No problem.
and
Uh,
also like the last 5 minutes of last class, the Wi-Fi like stopped working, so like I don't like I never heard like the last 5 minutes of like last class.
Okay, don't worry. I'll share the recording with you, and if you have any queries, you can basically ask me. Please don't worry on those, things, or we can
Okay,
repeat the class again. So let's do one thing. Let me finish this class, let's say in an hour, or I'll give you those recording. Okay, and then you can take the notes from that. I'll share the recording on the group. You can take the notes, and we can discuss in depth again if you have any question or a problem. Now, today, what we
okay,
are trying to do, we are trying to understand how intelligence can be fed to this robot, right? There are some developed industry robots. We go to that level as in current level to understand, rather than doing some theory. Let's try to understand practically how these robots work for us or what they can do for us, right? So let's try to understand from a robot. Where is that robot thing? Altas Auto Do. Okay, let's try to understand from this robot called oh, I forgot the name again. Dot. They call it Dot. Let me start the video and we'll understand this. This is a simple video, right? Let me share this thing. I have to go here. I have to stop share. I need to share again. And where's that? Yes. Could you see this, fellow with
Yes,
two
sir.
watches? I don't know.
We can see it.
Okay. Let's try to understand how he talks about this robot. Okay. It's a good video. Okay, could you see what he's playing? That's a kind of remote of that robot,
Yes,
remote
sir.
of
The
that
yeah,
remote.
dog on the spot. Let's see.
What's up? MKBHD here. This is Spot, the Boston Dynamics robot dog. So you may recognize the name Boston Dynamics from these kind of terrifying videos from a few years ago. You might have seen these, or maybe these, part scary, part maybe a little sad.
See, this is how they build these robots. Self-balancing. They have some gyro sensors. They have these, four thing. They were basically trying to build something which can walk down with a carrying load carrying capacity. That's how Boston Dynamics was doing research. This is a research of past 25 years. This doesn't happen in a night. And this is one of the most advanced robots we have. There are three with Boston Dynamics which are commercially available. So these are the repetitive build robot, the programs which are really stabilized and released to the commercial. So what do you mean by commercial? When you sell something to somebody, they pay you, right? And this robot cost you around 70,000 American dollars, 70K to be precise. So it's really costly. So the programming, the robot, and it can carry up to 1.5 tons. The robot which we are trying to see right now is a was in a research development stage, which is now around 1.5 months before. Okay. Now, if you go to Boston Dynamics side, you can see the name at the lower bottom. You can see for yourself also. These are the one of the most developed robots. They've done a good research, and let's try to understand how this robot works. Right? What are the applications? What are the things they've implemented in them? So this is kind of understanding robots.
Videos.
So $70,000 in Indian currency is 52 lakhs.
Yeah, that's quite a lot. I know, I know.
So, sir, there's these dogs. I saw videos, sir, before. They use these dogs, sir, for bombing, sir. They put bombs in this and send to like terrorists. other
We
countries when
will
war
see
is
that.
going.
We'll see that. Yeah, we are going to see those applications. That's really great. Okay, that's what we're trying to understand. There are 3 commercially available robots from Boston Dynamics. What we're trying to do, we're trying to understand how these robots are advanced as of now, and then we'll see how we can build one for us. Okay, what we understood expert system. We understood different things which we can learn from these guys. Okay, let's see.
It being spotted out in public that I tweeted with some feelings about it in 2020. But I think a lot of people, when talking about it, saw that.
Sir, the audio vanished. We cannot hear.
The audio turned off.
Up in Boston with the team that actually. What's up? MKBHD here. This is Spot, the Boston Dynamics robot dog. So you may recognize the name Boston Dynamics from these kind of terrifying videos from a few years ago. You might have seen these, or maybe these part scary, part maybe a little sad videos, or even this recent video of it being spotted out in public that I tweeted with some feelings about it in 2020. But I think a lot of people, when talking about it, saw that one Black Mirror episode, which may have been loosely inspired, okay, maybe heavily inspired by the Boston Dynamics projects. But this is dope tech, and I actually got to spend some time up in Boston with the team that actually works on this. And so here, I'm going to show you everything I learned about what Spot actually is and what it can actually do right now in 2020. Okay, so what is Spot? So Spot is a quadruped robot that's basically a computer, battery, and sensors all together on top of some motors and metal and joints in the shape of legs. Does that make sense? Spot is mostly metal, so weighs around 60 pounds, pretty hefty, and it's the most refined version yet of this remote-controlled dog concept. So you can see there's 5 sets of cameras all around. There's 2 main sets in the front. We'll call that the face. And then there is a matching set on each side and a set of cameras at the butt. So each one of these cameras sees in stereo vision, and along with gyroscopes and sensors inside, all of this is feeding information to the computer at all times about how to control the motors to keep Spot balanced. So take that, then add some shoulder harnesses to pick it up, some rubber nubs for feet, and some appropriate ventilation for the computer inside, and you got yourself a robot dog. And of course, one that looks a lot more slim and friendly than previous iterations of the robot dog. Maybe the best example of that is the battery, actually. So Spot has a little interchangeable battery in the belly area. It's an 11,500 milliamp hour battery pack, and that powers Spot for around 90 minutes on a charge. But that, of course, depends on the payload weight and how much you're actually using it. Matter of fact, Spot is actually using energy here, actively balancing, even when it's just standing still. So your mileage may vary. So Spot's controller is essentially an Android tablet with some buttons and joysticks. And so it's running a Spot Android app that Boston Dynamics coded so it can talk directly to Spot or even via a remote connection from many miles.
You can use your mobile as well. There's a Spot application if you have a latest, Android 10 or Apple, tab. You can use with that bot. But it has some restricted functionality. If you purchase this, tablet or what they call bot controller, Spot controller, it's much easier that way. This is what the Spot controller is all about.
And honestly, the most impressive part of the controls was how easy it was. Like I got maybe a 90-second demo with the controller, and that for me was enough to know maybe things that Spot can do right off the bat. Maybe it's because I loved RC cars. I was always into this type of thing, but it was super simple. So the left joystick moves the robot forward and backward and side to side, and the right stick is just for rotation, clockwise or counterclockwise. So you basically combine these 2 joysticks and you can direct Spot pretty much anywhere you want him to go. The screen, as you're moving, will show the camera feed from any of the cameras you want. Of course, it's helpful to have the forward-facing camera pulled up, and that gives you a pretty good idea of where it's going. And then you can also change things like the height and the speed. So Spot likes to be about in the middle height as he's walking for efficiency and balance, but you can change that. And you have up to 3 speeds: slow, medium, or fast. Spot can go actually up to 1.4 meters per second, or about 3 miles an hour in fast mode. They've tested faster speeds, but this gait is a lot more approachable and stable and predictable. So Spot has a couple modes. Some of them are perfectly reasonable, and some of them just kind of feel like showing off. First of all, Spot can sit and turn all the motors off, of course. So when it's in sit mode, it's just chilling. You can turn it on, and then it'll go into stand mode. And in stand mode, you can move it around to look around without actually walking. This might be when it looks the most dog-like, and it can give you a little head tilt and all this crazy stuff. But like I said, when it's standing, the motors are still on for self-balancing, and you can quickly see if a strong wind blows, or even as I literally try to push it over, it catches itself and stays on its feet. So that's stand mode. Then there's walk mode. Okay, so this is a normal walking gait that you see the most often. It's taking one step forward with the diagonal opposite leg, like a normal dog would walk, for example. Front left, back right, front right, back left. And this is the mode that goes up to its max speed, which is honestly faster than it sounds. Now, it is only 3 miles an hour, like I said. You can definitely still outrun it, in case you were thinking about that. But it's still impressively fast, and just the way the legs move so crazy quickly and fluidly and confidently is wild to watch. Then there's crawl mode, which is a bit slower, but it's being a little bit more careful, more deliberate. That's keeping 3 paws or feet on the ground at all times and only lifting one at a time. So that's useful in more loose gravel type situations, uneven terrain. Then there's a hop mode, which, okay, now that just feels like showing off. Like the robot hops back and forth between paws, 5 on one side, 5 on the other side. I don't know when you would ever need to do this. It's just more using energy, and it isn't super efficient. But, you know, if you slow it down in the footage, you can actually see that Spot is completely airborne off the ground between hops, which I guess makes a cool demo. Most of Spot's time, though, I think will be spent in walk mode, where it can handle the vast majority of surfaces and pavement and all that type of stuff. Even if it's uneven, Spot walks over debris and branches and up and down hills through shrubs, basically, typically with no problem. And on flat ground, it just makes it look easy. It looks like another dog. That is until it gets to a set of stairs. Yeah, so Spot has a stairs mode, and it's really good, as you can tell. It kind of effortlessly, naturally glides up this very specific man-made creation that is a set of stairs. And it can go forward or backward. Spot doesn't really care as long as it can see where it's going. And that, to me, was really impressive. Every paw immediately went up to the next step, down to the next step, and there was never any hint of hesitation or slowing down. And this stair climbing is just a small sign of Spot's greater intelligence. Okay, so Spot is actually smarter than he seems. I am holding a controller most of the time, but that's only part of the story. So like I said at the beginning, Spot, it's a computer, and the computer is using all these sensors and cameras to build a 3D model of the world around it in real time as it's walking. That's what the computer's doing. And so because of that, there's like obstacle avoidance and ground height detection. And they work really, really well. So basically, when these smart features are all on, pressing the joystick forward is merely a suggestion that the robot should go straight forward. But like I can walk Spot right at this box, which is an obstacle, just holding the stick forward, and you can see Spot drop a shoulder and dodge it to walk around it. That's completely on Spot's own awareness. That's the robot doing it with no extra input from me. I was just telling Spot to walk forward, and he did the rest. And the ground height detection is important too. So it's always mapping what's in front and the height of what your next step should be. So with that feature turned off, you can actually see it walking into a curb, and it kind of trips its way onto the higher ground before correcting itself. But with that feature on, it already knows to take a higher step when there's a curb in front of it. It doesn't trip at all. And if there's ever an obstacle in front of it, it's mapped out the whole thing, and it already knows how high each step should be to climb over something, like a real dog would know if it was walking over the same thing. But I will say, Spot is still a robot, and so it is, after all, not exactly perfect. Part of what they will do out here near Boston is push these robots to the limit to try to find what needs improving, to figure out what can be built better, smoother, or more consistently. So, for example, one of the situational awareness areas that Spot needs the most work is object detection, because Spot's cameras have a hard time telling what objects are solid versus not so solid. So where a human would instinctively know you can't step on snow the same way as rocks or dirt versus leaves, sometimes Spot has to step on it to figure it out. So sometimes things like bushes or plants can confuse him when he thinks he can't step on them. So, yeah, no robot is perfect, but you have to remember, that's the whole point of this testing. They're always pushing it to the limit to figure out how to make Spot better, and so they will often fail. What happens when Spot fails? Well, as you can see, he's gotten pretty good at this whole self-righting thing to get back up. So if he's fallen down, he can self-right. Even if he's upside down, they can flip back over. And as we saw, a lot of times, he'll catch himself before he's actually fallen in the first place. So he does a pretty good job of avoiding failure, but if he does fail, he has a move to get out of it. Okay, so probably the most common question after seeing all of this is, why? Why have you created this? Why does Spot exist in the first place? And the answer, I actually think, is pretty simple. Think of it as the Mars rover for Earth. So we sent a rover to Mars because it was impossible, or at least way too risky, to send humans to Mars to do this job. But we wanted to send someone, something, to take photos, collect soil samples, take measurements, conduct a few experiments, and send the results back to Earth. So that's how we got the incredible Curiosity rover, and more recently the Perseverance rover that just launched less than a month ago and is scheduled to arrive at Mars to conduct more experiments in February of next year. So I think of Spot as the same thing for Earth. You can send Spot into dangerous, partially collapsed buildings, through remote tunnels, through extreme weather conditions. You can send it into a house with measuring equipment to get a measurement to see if the air has been leaking any sort of toxic gases. You can send it all sorts of places that you wouldn't want to send a human because it's too risky or they couldn't do it the same way. So you see these rails up here at the top of Spot? That's for standardized mounting hardware. And these two rubber nubs, these are actually covers for data ports. So with the rails and ports, you can attach modules to Spot to carry out these types of surveying, mapping, and measuring tasks. And that's what makes him so useful. Also, I'm not sure if Spot is him or her or it. I don't know. It's a robot. Either way, Spot has also already been useful in construction environments where clients have mapped out predetermined routes with no controller needed. So Spot can go in this construction and take progress photos from the exact same angle and location every day for several days in a row. Like, that's something humans honestly probably wouldn't even be that good at. There's also companies working with Boston Dynamics on building modules.
These images, these red, all these things, these are thermal scanners. Okay, on LiDAR, LiDAR we see that laser gun, right? This laser gun can sense temperature also. So they collect these images. Now, why these colorful these things? Where we basically trying to understand how the responsiveness of difference in surface area. So wood at a different temperature, cement, concrete at a different temperature, plaster of Paris, the walls we have in North America, that's of a different temperature. The POP we use for ceiling, that's has a different temperature, so on and so forth. So we try to basically build these things to understand how the things are going, step by step of understanding that environment. Okay.
Location every day for several days in a row. Like, that's something
So if you have a bomb, if you have, let's say a bomb made it of plastics mostly, right? Because they build a, what you can say, container of a plastics before, whenever you install a bomb. You can't use steel because that will basically reduce the overall efficiency of a bomb, right? So for that matter, we can understand the plastic very easily from the iron because of the heat temperature of the surface. And these are the intelligent things which we build in such robots. And that's how it's used.
Humans honestly probably wouldn't even be that good at. There's a
Could we see those colors? Have you seen, you with your blind eye, could you understand difference between plastic and, metal? We can't, right? We can't do that because plastic and, metal looks same to us. But for robots, they can go to that level of sensing temperature change, the depth of the material in some scenario with the LiDAR and all. So that's how they can detect different surfaces.
So companies working with Boston Dynamics on building modules for their own applications. And Boston Dynamics has built a few of their own, mostly involving cameras and radar and mapping software. And so Spot is simply a vehicle that will carry these modules around, a really advanced, lifelike vehicle with 4 legs that obeys your every command. Now, if after seeing all this, you're still concerned about the potential future from that Black Mirror episode, don't worry. The people who work here have seen that episode, and they have no intention of creating or allowing a future where robots just take over the world. But it's also super crazy to think about, if this is Spot now, and this was the robot they were working on 7 years ago, what does...
Could you understand from 7 years? Where we've reached, to what point. And this is how the evolution works. This is how we basically keep building, our, what you can say, intelligence system step by step. And that's the most, fun part of it.
Spot look like in another 7 years? Or what does Spot in 2030 look like? 2040? That's what's really exciting to me. And as it continues to get smarter and find new applications and accomplish new things, I can't help but feel a little bit proud of Spot and how far it's come. But it truly is dope tech because of its potential for the future. And I'll certainly be keeping my eye out for it. So, hey, no need to shut it down, Boston Dynamics. I like what I've seen so far. That's so far, anyway. Thanks for watching. This entire video was edited by Spot. No, I'm just kidding. Catch you guys in the next tech video soon. Peace.
Okay, so I believe you understand how, the robots have been improvised till this time. We've seen a complete growth path. We've seen what is used for. I've shared this video already on the group, so you can have a look at it. And what I would really, want from you is write a 2-page summary of what you think a robot should do. Like, write in your own words. Okay, you can have a look at these videos, try to understand. But what I want to really understand as a person, as a human being, why I want a robot. Let's try to write down an essay on robot of what I want my robot to be capable of. Okay, could we do that? What this will give me an idea of how do you think in terms of where we can use this technology, where we can use this artificial intelligence. And then we also basically going to look for building a robot for ourselves, right? So what I want to, really understand, we normally build this robot, frankly speaking. This is called Thomas STEM project. It's a, 12-hour project. Means if you get, purchase this thing at $1,000, you can have around 12 robot, which is,
Your voice is breaking up.
Things can be built by these things. In India, I think it's cost around, I don't know, I'll try to speak a bit slower. Give me a minute. It might it's a problem. Okay. Could you hear me now? Is it better?
Yeah, now it's better.
Yeah, sometimes we do have some, internal lags. That's what we call. Okay. So we're going to build a robot called Thomas STEM project, which is easily available. It can come to you within a couple of days. And we need to assemble it. There's no soldering required, but yeah, we need to clip it. We need to tighten it with a screwdriver. I believe we all know how to use screwdrivers, right? Raise of hands. Okay, you do. Okay, chalo, great. So that's more than enough. We are not going for a soldering robots and all. If you can do this, or if you can excel in this, we can go for a soldering robot after that. But then we need to have some senior supervision, like mother, father, or elder brother. But yeah, that's a kind of next step. So this is what I'll basically put it on a group as well, as a link and as a picture. So you can start
Sir,
ordering this thing. Yes, Darshil, please go ahead.
sir, I have the robot, sir. I have completed it quarter. It's very
Oh
hard
wow.
to do.
Okay.
I have quarter complete.
Oh, that's great. So next time, could you please show us whatever you build? Have you that with you?
Not right now, sir. I'll
No, no, no.
build it and show you completely.
Okay, okay. Let's try to have what the she'll build in our next session, right? And let's try to understand what are the different sensors we are using, how they work together, and let's try to understand the internals of it. Building a robot is one thing; it's a labor work, but trying to understand how these sensors are performing. So instead of 12, we can build 14 different models, right? Something like that sort. But once you understand the laser, the sensors, once you understand why it's reacting so, why the functionality is, getting executed in which sense, which way, we can build it better, right? Could you understand me, what I'm trying to say? Okay, great. So this is what we will build. I'll put this in a group, and as I promised you, I'll also put the link of last 3 recording sessions. So whenever you want to have, you can have a look at them. Okay. And what I want from you is basically a 2-pager summary of what you want your robot to do. Let's try to understand. Let's try to scratch our gray cell and try to build something which is useful for us. Me as a Ravindra person is much different from your thought process, right? So I want to understand your thought process as in person, as in human, as an intelligent human being, what robot should do for me. Okay? Is it easy enough? Can be done?
So that means by next Thursday we have to prepare the robot that you are showing on the
No, 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 no,
presentation.
no, no. You have to prepare robots. This is I've shown it because we need to procure, right? You need to purchase this kit. You need to order them if you haven't done it. If you've done it, no problem. We'll build it again, rebuild it again. We'll try to understand how you build it, and we'll share those thought process together.
So
This is
is this
like
a homework? Is this a homework?
the homework is basically as in person, as in Darshil, as in Kaushik, as in Ishan. What do you want your robots to do? You've seen that Spot, right? Boston Spot. Now you've seen what it can be, it can perform, what it can do, and all those things. But as in human being, as in persons, as an intelligent thing, we need to design, we need to define what I need to get it from the robots, and then we'll start building, right? So for that, we need to understand what I want first. So I want from each of you to understand what you want your robot should do. Simple enough.
So you're asking so you're asking to like we have to make like a 2-page essay and like what we want this robot to do, like this one
Perfect.
like on
Not
the
this
screen.
robot, any robot. What
Okay.
you want to design a robot. So what we will do? What are the 10 different tasks he or she should do? Let's it. Let's call it it. It is a normal, goes with English linguistics. What it should do for you? Let's say 10 difficult things which you find really boring. I find making tea really boring, and I'm just throwing a sample here. So what I want to do, I want to build a robot, but I need to think it through. How will build tea? Is it easy enough, or is it too costly? Because we understand, right? What do you mean by expert system? Yeah, Darshil, I'll just review it for you. We've discussed about something called expert system. Okay, where the hell is gone? Okay, normally in AI, there are 2 separate or independent goals we normally talk about whenever we try to discuss about building a new things. There are expert system which do repetitive things. So singular repetitive things in non-expert. Dual repetitive thing is basically expert system. Okay, I'll share this even PPT with you so you can understand and refer to these things. And then there is something we pump in intelligence after trying to find out what are expert system. So what I want from you is basically, according to you as a person, what is an expert system? What do you call a system an expert which will help you out? It will do repetitive things, simple, but still, which are the things which you want to address to? And that's what I want from you. Okay, have you understood? Any question, confusion for me? Do you have to buy that? Yes, Ishan, if you haven't bought that, you might be, start processing or, purchasing that. We'll have the shield to basically also show it in our, if possible, in our next or next to next, wherever possible, the shield. And, we can look at it, but still we keep learning, right? But these purchasing or procurement take couple of days or a week at the most, right? So I want that robot to be ready with us so that we can start building step by step. It takes around 2 to 3 sessions. So it's not really that quick. And we need to understand those sensors and how we leverage those sensors, how we use those sensors with us. Okay, and that's the fun part of it. Okay, so I'll share this PPT, I'll share the past recordings. I've shared the video of the dog or bot, whatever you want to call it already. Okay, so happy learning. Let's stop here so that you can revise, and please do write those essays. Those essays are important for us to understand what I want to be, my robot to do, right? So those kind of scenario. Okay, so anybody have any question for me at this moment? We are good, right? Okay, so let me stop my session here. Have a great day today, great evening today. Let's meet
I have
on
one
Thursday
question.
again. Yeah, please go ahead, Kaushik.
Like what class do we need the robot by? Like next class or like in 2 classes?
No. Kaushik, I think I'm giving you a plan ahead for at least 2 weeks.
Okay.
So right now it's 20th June, 28th June, right? So we won't need it till 12th July. So don't worry on that part. And we can basically move here and there. Don't worry. Okay? Chalo then. Any other question here? Okay, great. Chalo. I'll say goodbye. Have a great day. Bye-bye. Take care.
Bye.